Hello, and welcome to this session for Azure Back to School 2024. This session is called Azure Networking, an Essential Skill for Cloud Architects and IT Professionals. Before we begin, I just want to say a quick thank you to the event organizers, Dwayne and Derek, for organizing this event once again. I really enjoy taking part in this event each year, and there's always loads of really great sessions throughout the month of September. Also, a quick thank you to the event sponsors this year. That's Captain Hyperscaler and Trace3. So just before we begin, I'd like to do a quick introduction about myself. My name is Alan Canan. I am a Microsoft MVP in the Azure and Security categories. I'm based out of Dublin, Ireland, where I work as an Azure practice lead. You'll find my details on the screen. If you'd like to connect, you'll find me on Twitter and LinkedIn. And I have a blog on www.azureallen.ie. So just before we begin, I thought we'd have a little bit of fun with a quick history lesson. Did you know that the first intercontinental subsea cable was laid between Ireland and Newfoundland all the way back in 1858? It ran from a place called Valentia Island off the west coast of Ireland in County Kerry all the way over to a place called Heart's Content in Newfoundland. And this connected the continents of Europe and North America for the very first time so that they could communicate through a single cable, which was 3,200 kilometers in length. It was a copper cable that was wrapped in a plant-based rubber and then surrounded by iron. And although the cable worked, it was extremely slow, especially by today's standards. So it only allowed about 2 characters per minute via telegraph, which is effectively Morse code, to be sent. So as an example, one of the first messages was a 99-word message sent from Queen Victoria in Britain to President Buchanan in the US, and that took 17 hours in total to deliver. The other bad thing is the cable was very unstable and it only lasted a few weeks, in fact, before it was basically useless. So a success, yes, but didn't last too long. A new cable replaced that one that was laid in 1866, and it was already a big improvement, about 80 times faster, which allowed 8 words per minute. Although that's still extremely slow by today's standards, it's a lot quicker than sending messages by ship, which took about 10 days at the time. Obviously, nowadays, technology has moved on quite a bit since then. We've plenty of subsea cables. The most recent transatlantic cable was actually only laid last year in 2023, and that connects the US continent to both the UK and to France. It's longer in length, close to 7,000 kilometers, and it consists of 16 fiber optic pairs. So combined, that cable has a capacity for 400 terabits per second. If you want to compare that to the original cable, it's about 6 quadrillion times faster than that first cable. So that brings me on to my session, what it's all about, networking. So there's a map of the Microsoft network connecting 60 plus Azure regions, over 200 data centers, and over 165,000 miles of fiber cable. But isn't networking just for servers and virtual machines? What if you're not interested in that? You don't do infrastructure as a service, or you're cloud native, or you're a developer. I have no interest in networking as a developer. Well, believe it or not, everything in Azure runs on VMs. Yes, it's true, Microsoft managed most of those VMs for you. So all those platform services you might work on are mostly managed by Microsoft. But networking still applies to all of those services and solutions. And while Microsoft may manage a lot of those settings for you, it is really helpful and important that you understand what those settings do and how they're used. Important for things like security. So private networking is a crucial element of zero trust architectures. That's something you've probably heard a lot of over recent years, zero trust. And those platform services can also be privately networked. So a number of years ago, they all communicated over public endpoints. But nowadays we have things like private endpoints that allow us to make those platform services private and connected to our virtual networks. So we have more secure networking for zero trust architectures. So planning is very important in networking, and it should be done as early as possible in the design phase. And that's the focus of this session today. We're going to talk about networking, why it's important for all of those roles. Even if you're not an infrastructure person, it's still really important to understand networking and to include that in your design phase. So if we look at my agenda for this session, I'm going to first of all talk about virtual networks themselves, what they're used for. We'll talk a bit about routing, how those networks communicate to each other. Again, it's a very important element to understand when you're getting into networking. We'll talk about hybrid networking, how we can connect our Azure virtual networks to networks outside of Azure, such as on premises. We'll cover a little bit of network security. That could probably be an entire session or an entire day of sessions in itself. We'll cover some of the basics about network security. And then we'll talk about connectivity troubleshooting. What tools are available? How can we troubleshoot when our traffic does not flow successfully from A to B? So there are some useful tools available to do that, and it's important that you understand what those are used for and how to use them. Because in IT, things inevitably will go wrong at some point. When it comes to networking, we need to be able to troubleshoot that as best as possible ourselves. Okay, so let's first of all start talking about virtual networks. So a quick introduction to what virtual networks are. Firstly, they are software-defined logical networks. And what this essentially means is that these softwares are created and managed through software. So there's no hardware requirements for this. That's all managed by Microsoft, all the switching and cables and stuff like that, managed by Microsoft. You just create whatever networks, whatever logical networks that you need to create using the software of Azure Resource Manager. So that can be done through things like infrastructure as code, scripting like PowerShell or Azure CLI, or of course the Azure portal. So you get to define and shape these networks as you see fit, and then you can put in things like routing and connect those networks up and allow the traffic to flow how you want it to flow, all through the magic of software-defined networks. These are fundamental to many Azure services. I mentioned already, these are not just used for virtual machines anymore. That was the case early on in the days of Azure. It still is a prerequisite for Azure virtual machines. You need a virtual network before you can create a virtual machine in Azure, but they're not just used by VMs anymore. So all those platform services that now have a feature called private endpoints, if you want to enable that private endpoint feature, that means you're creating a private IP address, which needs a network interface card resource, and that needs to be connected to a virtual network. So very much a fundamental service for many, many Azure services nowadays. Those networks that you create are logically isolated by default. So all those data packets that are flowing through your virtual networks, those are encapsulated within the Microsoft shared network infrastructure environment to ensure that your traffic is isolated and kept separate from your other virtual networks and also from other customer networks. Remember, obviously, you are sharing Microsoft's network infrastructure. You've got many, many customers using that. All that traffic must remain separated, and it is by default. So even networks you create yourself by default will be isolated. We'll talk a little bit later on about how you can connect your networks together, which is a very common requirement. They are also regional resources. So when you deploy a virtual network, you must choose one of those Azure regions that are available. So for example, you might choose West Europe, and it means any resources connected to that must be in that same region. But of course, you can connect your networks from one region to another region. So if you've got resources in West Europe and you've got resources in one of the US regions, you can deploy a virtual network in the US region and connect those two virtual networks together and allow those resources to communicate. You can also connect your VNets to other clouds, private data centers, anything outside of Azure, really. So again, through the magic of networking, that allows you to extend maybe your on-premises footprint into an Azure virtual network. Or if you're using multi-cloud and using maybe AWS or Google, you can connect to resources there as well. So some of the capabilities of Azure Virtual Networks, obviously communicating between your Azure resources. And again, it's not just VMs talking to each other. VMs might need to talk to some platform services and vice versa. You might need to communicate between your Azure environment and resources outside of Azure, such as on-premises, as we've just mentioned. Communication with the internet. We've obviously got a lot of internet-hosted services nowadays, a lot of SaaS-based applications. Quite often you'll want to communicate outbound to the internet as well. Furthermore to that, we will want to filter that network traffic, secure it. There's various different methods for doing that, which we'll talk about later on. So your virtual networks are used for filtering the traffic and controlling that, and controlling the flow of the traffic as well through routing. So you may want to send your traffic out to the internet or restrict that, or maybe you want your traffic to flow back to on premises through like a forced VPN tunnel or something similar. So all of this is done through Azure Virtual Networking. So what do we do when we create a new virtual network? Well, first of all, why do we do that? Usually we create a new virtual network when we have a new workload to host. Best practice usually dictates that you don't put all of your workloads onto a single virtual network. Maybe for very small environments that will be useful, but for most customers, you're going to have multiple virtual networks and you're going to separate the traffic into various different virtual networks and then connect those networks together accordingly as required. It is a requirement for any Azure virtual machines. As I mentioned, that is a prerequisite. If you've got VMs, that will have to have a virtual network for it. Or if you're using that private endpoint feature of any PaaS services, again, you will need a virtual network for that service. When creating the virtual network, you define the address space that you want to use, and that must contain at least one subnet. We'll talk about address spaces in a moment, but that is a very important design point for when you're planning your virtual network environments, that address space that you're going to use. And then we can secure that virtual network with various different Azure services. Some examples would be Azure Bastion, Azure Firewall, DDoS protection, network encryption, and network security groups. We'll talk a little bit more about some of those in this session. So talking about the virtual network address space, as I mentioned, this is a very important consideration when you're designing your network. What you want to do here is a couple of things. You want to plan for future growth. So even though you may have an idea of what you need to host today, you want to make sure you're allowing enough room for further growth of that network, i.e. hosting more endpoints on that network in the future and allowing for more subnets to be added. And subnet is a really great way for dividing up your network address space into smaller address spaces or groups of address spaces. And that can be great for adding more workloads to that network in future. What's important here is you do not overlap the address space with other networks. You cannot connect two Azure virtual networks together if they have overlapping address spaces. And while nowadays you can connect a virtual network to, for example, an on-premises network that has the same address space, you are adding some complexity by doing that. So ideally, that's something you want to try to avoid. You want to try and keep your networking and your routing as simple as possible. So if you do have a particular address space that you use on premises, use a different address space in Azure as a good rule of thumb. So this is why it's an important design point to do this at the start. And in terms of security, good idea to build in those security services right at the start. So before you start putting things like machines up there, maybe you're doing a virtual machine data center migration, it's really a good idea to have those security services in place before you do any of that, to make sure that those foundations are there and they're all set up correctly and working before you actually do the migration. In terms of what you can choose, there's a standard set of address spaces you may be familiar with already. It's called the RFC 1918. And those address spaces are on screen there. Those ranges you'll be probably familiar with if you've done any on-premises networking previously. One thing that's important to note is that Azure does take 5 IP address spaces from your subnet for you at all times. So when you create a new address space in Azure, you'll find .0, .1, .2, and .3 are all taken by Azure. That's used for routing traffic through, a virtual default gateway and used for some DNS services. And also .255 is taken for network broadcast. So usually you'll find your first available IP address on an Azure virtual network is the .4 address. So it's just something to bear in mind when you're creating your subnets. You will lose 5 addresses from that. So make sure you allow enough room for all of your hosts and some room for growth. Another tip here is if you create a virtual network, or maybe a fairly small one, do not put all those addresses into a single subnet, because you may find later on there's a reason that you might need to add a separate subnet to that VNet. And if you've used up all of your addresses on a single subnet, you can't therefore add any future subnets. And you may find some services require a dedicated subnet. We'll talk about some of those services in this session. So in terms of subnets themselves, It's a really great way to segment traffic within that single virtual network. I mentioned already about using multiple VNets, but if you want to separate your traffic or micro-segment your traffic within a single virtual network, subnets are really useful for this. Because later on we'll talk about network security groups and show how you can segregate traffic between those subnets. So it's a great way to logically divide up your networks, helps you to improve security posture. You just need to make sure, again, those subnets don't have overlapping address spaces. Each subnet that you define must have a unique address space and they cannot overlap. And you might see from that diagram there, gateway subnet. So that's one of those services I mentioned already that require a dedicated subnet. So that's for a VPN gateway that in this case would require its own dedicated subnet. So you'd need to make sure you've left enough address space available for that subnet to be created. So why are subnets important? So we look at this N-tier architecture for a single virtual network. This is a really common design starting point for any infrastructure as a service projects. Maybe something you would have done on premises would look similar to this. So if you've got an application that maybe has a web front end and maybe a middle tier or business tier after that, and then finally at the back end, it's got a data tier. So that's where your databases go. If we think about this on a single virtual network, we don't really want to put all of those services onto one subnet. Ideally, we better to separate those tiers into different subnets. So one subnet would be the web tier, another subnet for the business tier, and then another subnet for the data tier. And then we can segregate that traffic from each other. So for example, we may need to open some ports to the internet for the web tier to allow some HTTPS traffic to come into the web tier. But we don't open those ports on the data tier, which sits on a separate subnet. Another thing is we may want the web tier to talk to the business tier and the business tier to talk to the data tier, but we've no reason for the web tier to talk directly to the data tier. So we can easily control that traffic later on when we introduce network security groups by having those tiers on different subnets. If they're all on the one subnet, it's a much more complex operation to do. So again, a common starting point for designs, especially for simple new web application architectures. And this is really just to showcase why you use subnets on your network. A much more common approach nowadays is using multiple virtual networks. So remember, these are always isolated by default. Every time you create a VNet, it is isolated by default automatically. You don't have to do anything to enable that, but you may want to connect those together later on. But you have full control over that. So you may have, let's say, 10 virtual networks. They don't all have to be connected to each other. You can pick and choose which networks can talk to each other. So that allows you to have really granular security and have full control over all of the routing yourself. This is also a really scalable model. So if you think about adding on future workloads, if you're always adding future workloads to a single virtual network, eventually you're going to run out of space, and it's going to become very difficult to maintain that. If you think about, well, I'm introducing a new system, which virtual network will I put it on? Well, let's just put it on a new virtual network just for that system. So it allows you to get very granular with keeping those applications separate on their own individual networks. These are regionally distributed, remember, so you can have multiple virtual networks in different Azure regions. So when working with virtual networks, we're going to have to decide what network topology we go with. And you've really got three options here. You've got hub and spoke, mesh, and a new one called direct connectivity. So just briefly on these three, hub and spoke would be, in my experience at least, by far the most common model. The idea with this one is that you've got a central hub network in the middle of the diagram there, and that's really where all your connectivity services sit. So that's where your firewall will go, that's where any VPN gateways will go, and that's about it. All of your applications then sit on separate spoke networks that will connect into that hub network. So all of the traffic is routing through that central hub network. That's your router effectively. If you need traffic to flow from spoke A to spoke B or spoke C, it all flows through that hub network. And if that's where your firewall is then filtering all of that traffic. So even if it's not leaving Azure and it's just staying within the Azure environment, you can route all that east-west traffic through that hub network. Second one then is a mesh network. And as you can probably tell from the diagram, that's where every VNet connects to every other VNet. I don't see this one too often, maybe for smaller setups. I prefer to have the central hub network where you've got a firewall and then you can make sure all traffic is routing through that. But in some requirements, a mesh network will do the job very nicely. But just remember, every network must have a connection to every other network for the traffic to flow. The last one then is direct connectivity. To deploy this one, you'll need to use Azure Virtual Network Manager, which at the time of this recording is a relatively new service, I would say. And this allows you to, again, connect virtual networks to each other directly, but this uses a newer technology that's part of Azure Virtual Network Manager. And that allows you to have direct connect routes through network groupings without using virtual network peering, which is something we'll talk about later, which is a more traditional approach for connecting networks to each other. But that's a new option that has, I suppose, more recently become available for us to look at. We're going to focus on hub and spoke a little bit more because, as I mentioned, this is by far the most common approach from my experience. So those spoke networks, remember, can be deployed into multiple regions. You may have a hub network in your main or your home region. And if you want, you could have those spoke networks in various other Azure regions and connected globally then across the Microsoft Backbone network into that hub network in your home region. So this is a way of getting centralized routing and centralized security services. So as I mentioned already, that's where your security services like your Azure Firewall would sit. Maybe your Azure Bastion deployment would sit there so you can remote into your connected virtual machines using Bastion. And if you've got a requirement for a VPN gateway, that would go on the hub network as well. You only need one VPN gateway, and your connected networks can only connect to a single VPN gateway. So that naturally fits in the hub. This is a highly scalable model. So when you've got a new application, if necessary, you just add another spoke virtual network to it and then connect in, same as the others. So it's very easy to just keep adding on virtual networks as required to this model without changing the overall design. Remember, all those connectivity and security services should go in that hub network, and any shared services, they should ideally go into a spoke network. The concept of putting shared servers into a hub network, it might make sense to some extent, but at scale, it's usually better to have those on a separate spoke network and just keep your hub network as simple as possible with just those connectivity and security services, and that's it. So I've mentioned virtual network peering or VNet peering a few times, and this is really Azure's native way to connect two virtual networks together. I mentioned already you cannot connect two virtual networks with overlapping IP addresses. That is just not possible. So again, when you're designing your virtual networks, make sure you're using different address spaces and they won't overlap each other. There's two types of this, regional and global. The only difference here is global just means you're connecting two virtual networks from two different Azure regions. Regional just means those two virtual networks are within the same region. The process is exactly the same. There's really no difference other than possibly a slightly different cost on the VNet peering charges. When networks are peered together, you don't lose any performance versus a single virtual network because all that traffic, remember, is software defined. So peering means you're using the Azure Backbone network. So you don't have a hit just because you decide to put a workload into a different virtual network. You really shouldn't see any noticeable impact on that. You can peer networks across Azure subscriptions and even tenants. So if you've separated your workloads into multiple subscriptions, which is, again, not necessarily a bad practice, it's very common, in fact, you can still connect those. And if you did need to connect to another tenant, maybe to another customer's virtual network for some reason, that is also possible. So you can connect VNets between different Microsoft tenants as well. And then finally, an important point at the bottom there, VNet peering is not transitive. So what this means is if VNets are not directly connected to each other, you can't natively route traffic from one VNet to another. The only way to do this is to have some kind of a router in the center. So with our hub and spoke model, where we might deploy a firewall such as Azure Firewall or maybe a third-party appliance called a network virtual appliance, that can do that routing for us and allow that traffic to be routed from one VNet connected to another VNet that's connected to the hub network. But otherwise, you can't natively forward traffic between VNets unless they are directly connected. So that's an important consideration. And that's why hub and spoke is a really useful model where you've got that router acting as a firewall in the hub network. Okay, so next up is routing. So let's do a quick introduction to routing and why this is important. So routing, as you may have guessed, controls how traffic flows through your virtual networks. The good news is this is mostly managed by Azure for you. So Azure will have a good understanding of what you've got deployed through software-defined networking. And as you start to connect virtual networks together, it will know how to route traffic between those virtual networks for you. And this is managed by Azure, but controllable by you via subnet level route tables. Any network interfaces used by network resources, such as virtual machines or private endpoints for PaaS resources, they all utilize these routes from those route tables. And you can also propagate routes from any connected virtual networks. So when you peer networks together, those two networks have to learn each other's routes. Again, this is done by Azure for you. And if you connect a virtual network to an on-premises network through maybe something like ExpressRoute or a VPN gateway, again, you'll need to learn the routes from the on-premises environment. And you can put these in yourself manually, or it can be propagated through things like BGP. The good news is routes can be overridden. So you always have the ability to put in your own user-defined routes to override any routes that Azure creates for you automatically. And that's important because while Azure does a lot of the hard work for you, it doesn't always do what you want it to do. And there are reasons where you may want to force traffic to go in a particular direction than the default one that Azure has decided for you. So just to talk about different route types, we've got the system routes, which are the ones Azure creates for you. So these are automatically created by Azure for you and put on the subnet level. You can't create these yourself. You can't remove them. But as mentioned, you can always override them with your own custom routes. Custom routes are those user-defined routes that I was talking about a moment ago that you can create yourself to override those system routes that Azure puts in place for you. And just to talk quickly about default routes, so you'll always have a default route, which is essentially the next hop for your traffic so that Azure knows where to send traffic destined for a particular address range. So when any traffic is leaving a subnet, it's going to a particular IP address, and you need to know where that's sent to. And that may just be straight out to the internet, or it may be going to another virtual network, or it may have to go to on-premises via a VPN gateway, perhaps. And Azure is generally pretty good at deciding on the default routes for you. So as you start to connect networks together, it will have a good idea where that should go. The main exception to this would be where you want to send traffic to a firewall. Azure doesn't necessarily know that you've put a firewall in place, and it doesn't know that you want to send traffic through that firewall for filtering. So that's where custom routes come in, where you want to say, I need to override that default route and put in a custom route to send the traffic not to the internet, but instead first to a firewall appliance. And that brings us on to those user-defined routes. So again, remember these are used to override those default system routes that Azure provides for you. What you will need to do is create a new resource called a route table, and then put in the routes that you want and assign that to the subnet where you want it to take effect. So if you don't do this, Azure will just use those default routes and send the traffic where it thinks it needs to go. So in that route table, you're going to have to specify a destination type. That'll either be an IP address range prefix or a service tag. So if it's an Azure service, you'll see a list of service tags available for you to choose from. But more often than not, you'll use an IP address range to say anything destined for this address range needs to go X. And that X is the next hop for that destination. So you have a few options there. You can keep it within the virtual network. You can send it to a virtual network gateway. So if you're sending it back to on-premises, for example, you'll send it to a VNet gateway. You can send it straight out to the internet. You can drop the traffic completely. So if you set it to none, it will just drop that traffic and it won't go anywhere, into a black hole effectively. But probably the most common option is to send that traffic to a virtual appliance. Virtual appliance is typically a firewall. So be it Azure Firewall or a network virtual appliance, which is a third-party marketplace appliance. You just send the traffic to the IP address of that appliance, and then that will know to route the traffic to wherever it needs to go to through its own policies. So how does Azure know where to route the traffic? Because invariably you're going to have routes overlapping each other, especially with big complex networks and big complex environments. You'll have route tables with multiple address prefixes that may overlap each other. So Azure follows a pattern of longest prefix match, which basically means that the longest address prefix defined in your route table will always win. So if we look at a simple example here, we've got two routes, route A and route B. And we've got an address prefix of 10.0.0.0/16 in route A and 10.0.0.0/24 in route B. If I was sending traffic to 10.0.0.4, it matches both of those address prefixes because it's within both of those ranges. But route B will be chosen here because it's got a longer prefix in /24 than the /16. So because that prefix is longer, Azure selects route B as the winner here. So in this case, it's going to send the traffic to the virtual network. It's not going to send it to a virtual appliance in this case. So where multiple routes contain the same address prefix, Azure will always take the user-defined route first. So in this case, we're using user-defined routes. That wins. If we didn't, it would prioritize BGP traffic. So that's traffic that you've propagated from other networks that are connected. And then finally, it'll choose the system route. It'll choose the route that it's put in place itself as the last option. But because user-defined routing is at the top there, you always have the control for where your traffic flows. You can always override what's being put in there by the system itself or by BGP and manually override the traffic to where you want it to go to. So why might you want to do that? Two main reasons. One would be firewalling. So if you've got a virtual appliance or Azure Firewall, for example, in your hub network, you might want to route all of the traffic through that firewall. So even if the traffic is just flowing from east to west within your Azure network environment, it's not even going out to the internet, you still might want to route it all through the virtual appliance so that's getting filtered. Azure Firewall then will forward it on to its correct destination. So you can just put a force rule in to send your traffic to that firewall or network virtual appliance. Another common reason would be for forced tunneling. If you want to send your traffic maybe not out to the internet, but back to on-premises. So some organizations might have an on-premises firewall, and they may have some policies in place that says all corporate traffic must go through this firewall appliance for logging purposes, perhaps. So if you've got internet destined traffic in your Azure virtual network, it may first have to go back to an on-premises through a VPN or ExpressRoute connection back to on-premises before it can break out to the internet. So you're putting in a forced tunnel to send all of that traffic back to on-premises first. And those would be two of the most common reasons for using user-defined routing. Something that's important to mention, and I think it fits in well for this session, is how internet access works for virtual machines on your VNet. So right now, and has always been the case in Azure, is that you get outbound access to the internet by default. For example, if you create a virtual machine, you will find that you can access the internet on that virtual machine. Even if you don't put a public IP address on that machine, it can still NAT out to the internet because Azure creates an implicit temporary public IP address and puts it on that machine for you to route out to the internet. That is all going to be changing from the 30th of September 2025 for any new deployments you do after that date. The reason they're doing that, it's for improved security. So they're saying, well, look, if you're making deployments in Azure, we want to make sure you have full control over how that accesses the internet. So if you want your virtual machines to have access to the internet, and don't forget, this can be important for many things, even things like Windows Update needs access to the internet, you need to put in an explicit route out to the internet from after that date for any new deployments. So there's a few common options for this. Azure Firewall or virtual appliance would, in my opinion, be the best option because it obviously gives you that extra layer of security and that it's filtering your traffic. So if you're routing it outbound through the firewall or virtual appliance, it's going to use the public IP address of that appliance to NAT out to the internet. You can also use something called a NAT gateway, which I'll talk about in a second. And that's a very simple way to do this. You can use an Azure load balancer, which can also snatch the traffic out to the internet for you. Or you can use a public IP address, an instance level public IP address, which is an IP address directly associated with the virtual machine. Not really a good option here because you have to apply one IP address per machine here. And at scale, with a lot of virtual machines, that's going to be a lot of IP addresses for you to manage. There's also a cost to that as well. Not really a great option for organizations that have a lot of virtual machines. So just something to remember, this is coming into play from September 2025 for all new deployments of virtual machines after that time. So I did want to mention a little bit about Azure Virtual NAT. So this is one of those options for providing outbound connectivity. This is a great service that's available today. And what this does is it simplifies the outbound internet access for your virtual networks. Very quick and easy to deploy. You just deploy this service. It can have one or more IP addresses attached to it. And then you associate that with the subnet or subnets within the virtual network you want to apply this. So anytime you try to access the internet, it will be routed through this NAT service, and it will use the IP address, the public IP address of the Azure NAT service itself. A common use case for this, I find, is where you need to maybe whitelist IP addresses. If you're using a service like Azure Virtual Desktop, where you may have a number of hosts, and perhaps they need to access a particular web-based portal, you might need to whitelist an IP address to allow you access to that portal. So if you're not using a NAT and you're just routing out to the internet directly, you're going to use that implicit IP address, which is going to be different for every machine, and it's going to change over time. Also, this is not going to work for new deployments after September 2025. So to get around this, if you use a NAT gateway, well, ideally use a firewall, but otherwise I would say use a NAT gateway to route your traffic out. And again, that's just going to use that IP address from that NAT service. So that could be a static IP address that will never change. And that's a very simple single IP address that can cover multiple machines, multiple AVD hosts, and a very easy and low cost way to get around such a problem. So it's a good service to be aware of. I just thought I would mention this as part of this session. All right, this brings us on to hybrid networking. So what is hybrid networking? This is really some options that you have for creating private connections to and from on-premises or other clouds so that you can connect those environments to your Azure virtual networks. So you have a few options here. You've got site-to-site VPNs or virtual private networks. You have point-to-site VPNs. We have Azure Express Route, and we have Azure Virtual WAN. So I'll just take you through each of these options in a bit more detail. First of all, virtual private networks or VPNs, probably the most common option, fairly low cost and relatively easy to set up. These are primarily used to connect your Azure networks to on-premises networks, but they can be used for other clouds as well. And the reason being is that VPNs are very common architectures. They use very standardized connectivity options that pretty much any provider will be familiar with and will use. Your traffic is encrypted over VPN before it is sent out over the public internet. VPNs do use the public internet, so it's not a private connection as such because you're using public internet infrastructure. So you're using an ISP here, but the traffic is encrypted. This is facilitated by a virtual network gateway, an Azure VPN gateway. You can also do this using a virtual appliance. So if you're deploying a third-party firewall from the Azure Marketplace, these will usually have their own built-in VPN options that you can also use. But usually the native Azure VPN gateway is the common approach here, and that would sit in your hub network that we mentioned before. You get two connection types with a VPN gateway. You get both a site-to-site and a point-to-site connection. And the differences are a site-to-site connection is a permanent connection between your Azure virtual network and your on-premises network. So this connects the VPN gateway to your on-premises VPN appliance, which is typically a firewall. And it enables then secure access between the on-premises network and the Azure network. So this would be an always-on IPsec or IKE VPN tunnel between those two fixed locations. You don't need to turn it on or turn it off. It's always on, running 24/7. The other option is point to site. So this is a device level VPN connection. So it's a VPN client that's used to connect individual devices. That could just be your Windows laptop for remote workers. So if you've got remote workers, they're not going to have a permanent VPN connection into a firewall at home. They're just going to connect on demand as they need to connect their workstation or their laptop to your Azure environment. So this is usually either an IPsec or OpenVPN connection, and it can be authenticated in a few ways. You've got client certificates, you've got Active Directory via Radius servers, and now you've also got Microsoft Entra authentication to use to authenticate your point-to-site connections into Azure. So a little bit about the VPN gateway service itself. I mentioned before that all services in Azure, or most services anyway, are managed VMs. So this is no exception. These are a pair of virtual machines that are hidden in your virtual network and managed by Microsoft. And that's used to allow VPN connectivity in a highly available configuration. That's why there's two of them. As mentioned, this VPN gate will give you the option of both having site-to-site connections and point-to-site connections. So you're getting the flexibility of having both of those if required on the same VPN gateway. And you have a few different configuration options. By default, this will be in an active standby setup. So one of those hidden VMs is active and serving the VPN traffic, and the other one is there in a standby mode. So it's there to become active should the other machine experience any difficulties. And that's managed automatically for you by Microsoft to keep that solution highly available. You can configure this so that both of those VPN nodes are active at the same time. That's called active. That will require a higher SKU of the VPN gateway, but that is something that can be configured if you require both nodes to be active at the same time. There's support for this for BGP route propagation. So if you need to bring your on-premises routes into your Azure network so that it knows those routes, so you don't have to set them up yourself, that can be configured as part of the VPN gateway. Again, you'll need a higher SKU for that. And the last one there's an important point. This requires a dedicated subnet on your virtual network. So if you're deploying a VPN gateway to your network, it needs to go on its own subnet. You cannot have any other resources on that subnet. Well, you can, but you'll run into routing issues if you do that. So that's why you need to make sure you've left enough available addresses on your virtual network to deploy this dedicated subnet for the VPN gateway. And just one other thing to note here, this does take about 45 minutes to deploy. So if you're using this as part of maybe a disaster recovery environment, I always recommend build this ahead. So you've got a VPN gateway configured, up and running, so you can route traffic from on-premises to Azure. You do not want to be doing this if you're in a panic and you've got an outage and you're in a hurry to get this deployed. So build ahead. It's a slow deployment, but once it's deployed, it's one of those permanent fixtures that will just stay there. So while VPNs are a common approach, and as mentioned, fairly low cost and relatively easy to manage, sometimes you might need something a bit better, something that has more bandwidth and is more of a private connection. So that's where Azure Express Route comes in. So this will provide you with layer 3 connectivity between your on-premises environment and your Azure network. So you'll be using a service provider to provision this service for you. That will give you a connection speed of at least 50 megs per second, but this can scale up to 100 gigabits per second if you need that kind of bandwidth. So really what you're doing is you're integrating an MPLS connection from a service provider and allowing that to give you direct connectivity into the Microsoft network backbone. Another reason for using ExpressRoute is the SLA you'll get on this. So remember, if you're using a VPN gateway, you are routing your traffic through the internet. You're using an ISP. So an ISP is not going to stand over that and give you a service level agreement. If you're using ExpressRoute, you are buying this MPLS connection from a service provider, and then you're using this ExpressRoute service from Microsoft. Again, some organizations will need that kind of an SLA. They won't be able to depend on VPN gateways, which they might still use maybe as a backup option, but they will need a dedicated connection with a service level agreement. The final option then is Azure Virtual WAN. So this is more like a traditional SD-WAN approach. Really, I see this used where you need to combine the use of those different types we've mentioned already. So if you're using a combination of site-to-site VPNs, point-to-site VPNs, and ExpressRoute, you can manage all of these together using Azure Virtual WAN through connected hubs. So you're integrating using a hub and spoke model here, transiting all those connections through a centralized Azure Virtual WAN hub, and you'd have one hub per region. So if you're using, again, West Europe, you'd have a hub in the West Europe region. And this is a good way to visualize end-to-end traffic flowing through Azure, where you've got all of those different connection types. It's a nice way to manage those together. You can also integrate this with an Azure firewall, or if you're using an NVA SD-WAN solution, a number of these are now supported by Azure Virtual WAN. I don't see a huge use case for this. For bigger customers, it can make sense, especially if you've got branch offices all over the world. It can make things a bit easier. But it is another option for connecting your Azure networks to networks that live outside of Azure as well. Moving on to network security next. And a quick introduction to network security. Obviously, quite a complex and comprehensive topic. We won't be able to cover a huge amount in this section because it is so extensive. And ideally, security, as always, is a multi-layered solution. In terms of network security, you want to try and cover your network, your transport, and your application layers. On the network perimeter side of things, we have a few services available. There's Azure Firewall, or network virtual appliances, which are third-party appliances you can deploy through the Azure Marketplace. That will filter all of your traffic on the perimeter level. We've got a WAF service, Web Application Firewall, available on Azure Front Door and application gateways, protecting your web-based traffic at the perimeter. And we have DDoS protection. So Microsoft will always offer a basic level of DDoS protection on virtual networks. You can opt in for a higher SKU of DDoS protection if you want to configure that and have more control over the DDoS policies yourself. On the network and transport layer then, we mentioned already user-defined routes, and this is an important way to control the flow of your traffic and where that flows, send it to your firewalls, for example. We also have network security groups, which controls how the network flows within your virtual networks, what's allowed, what's not allowed. And we'll talk about that next. So network security groups, first of all, is a free service you can use to limit the traffic to resources within your virtual network. It's a list of security rules that you use to either allow traffic or deny traffic, both going inbound to your network or outbound traffic leaving your virtual network. You can associate these to either a subnet or to a network interface on that subnet, or both if you require. I normally find associating NSGs on the subnet level is the best practice, because you could just have one, and if you just have one NSG per subnet, it makes these much easier to control. And remember, have different subnets for different workloads within your virtual networks, and that's an easy way to segregate your traffic and have a set of rules applied to each subnet. They will therefore be inherited by any machines or endpoints that you put on that subnet. You can reuse these as well. So if you have a set of rules that you want to reuse for a different subnet or maybe a different network, you can reuse the same NSG. You don't have to have a unique NSG per subnet or per group. They can be reused. If we take a closer look at the NSG rules itself, when you create a network security group, you will see a set of predefined rules. You'll note these allow all VNet inbound and outbound traffic. These rules cannot be deleted. You cannot edit these either, but you can override these. So a bit like the user-defined rules in routing, you can put in rules above these, which will have a higher priority, which means they take precedence. So by default, you'll find all network traffic within your virtual network is allowed. So even if they're on different subnets, traffic flowing from subnet A to subnet B and vice versa is allowed. If you want to block that, maybe you don't want anything on subnet A from talking to anything on subnet B, you can block that with a block rule that simply specifies all of the IP addresses on subnet A flowing to subnet B are denied, and you can restrict those on ports and protocols as well, or just block everything. So it's a really powerful way for filtering traffic rules within your virtual networks and coming into your network and leaving your network. What's important to note is this only goes up to the transport layer. You're blocking or allowing traffic on port numbers and on protocols, and that's all. There's no application layer inspection with NSGs. If you need to do that and need to do any deep packet inspection, that's where you would need a firewall to come in. But the NSGs will take you up to the transport layer as a free service. And just as a quick example here, we can see although all inbound traffic is denied, so any traffic outside of the virtual network is denied, we have made an exception here with a higher priority rule to allow inbound traffic on port 3389 into the virtual network. So this overrides that 65,500 deny rule there. In terms of how NSGs are assigned and how they become effective, they are evaluated independently. So if you have put an NSG on a subnet and another NSG on a NIC, they will be assessed independently. So if you've got conflicting rules, you have to be aware of that. You need to allow traffic on both of those NSGs in this case. So if you've got inbound traffic coming into your Azure environment, it will hit the subnet layer NSG first. And if it's allowed to pass that, then it will get to the NSG that's on the NIC. And if it's allowed past that as well, then it gets to the endpoint. It's the opposite for outbound traffic. It will process outbound rules on the NSG on the NIC first, because that's what it hits first. If it's allowed past that, then it hits the NSG on the subnet. So it has to get allowed by both NSGs, but just note the flow is different. Inbound traffic is subnet first, then NIC. Outbound traffic is NIC first, and then subnet. You can probably see how this could get complicated if you're using a lot of NSGs, but there are some nice tools there to help you with this. And if you look at the effective security rules that you can see on the actual NIC resource, you'll be able to see what will apply to that NIC. So that can be a very useful tool to help you to troubleshoot. You can also use service tags. So this is becoming more and more popular as Azure services get added. So perhaps you're not using your own IP addresses. You just want to allow or deny traffic to various Azure services such as Azure Storage or Azure SQL or Azure Virtual Desktop. Well, rather than trying to look up all those IP addresses online and type all of those in yourself, you can actually just select that as a service tag. So a number of those are built in. That's maintained by Microsoft, and new services will be added as time goes on. And then we've got application security groups. This is not something I see a huge amount of usage for, but it can be useful if you've got a lot of virtual machines. The purpose of this is really logically grouping NICs together. So if you've got maybe a web farm, you've got maybe 20, 30, 50 web servers, you don't want to have to put in all those IP addresses into your NSG rules. They can be very hard to remember what they are, and knowing what they are at a glance if you're looking at your NSG rules and trying to remember what they refer to. So instead, what you could do is you could create an application security group. You could call that web farm, for example. And then you associate the NICs of each of those VMs in that web farm with the application security group. You're just logically grouping together all of the NICs of those machines into a single identifier. So rather than having to look at IP addresses, you're looking at an ASG name. So they can be used as the source or the destination in your security rule. All of those NICs must be in the same virtual network, so ASGs cannot span multiple VNets. And if you're specifying an ASG as the source and the destination, both the source ASG and the destination ASG must also be in the same virtual network. And just one more service I wanted to cover in this session about security, and that's Azure Bastion, which I would have mentioned a couple of times already. This is a really great service that provides a jump box or Bastion host for you to get remote access to your virtual machines. So if you're using Windows-based virtual machines, it's going to use the RDP protocol. For Linux, it's SSH. So rather than you opening ports on those machines directly, or you creating your own virtual machine as a jump box, this is a managed platform-based service that Microsoft provide exactly for this. So it's a really great way to allow administrative access to your own VMs. And fairly recently, there was a new SKU released of this service called Azure Bastion Developer, which is actually a free service. It does have some limitations, so just be aware of those. If you're building a production environment, it may not be suitable. But certainly while you're testing or building out that environment, that's a really great service to use to access your VMs. So it just saves you having to go to the trouble of creating IP addresses and opening ports and then potentially forgetting to remove those later on. So Azure Bastion is a really great go-to service for securing access to your virtual machines. Okay, so finally on to connectivity troubleshooting. And the purpose of this section is to give you a few ideas of what you can do if things don't work. So with networking, it can be complicated, and while you're building out environments, it can be very easy to make a mistake or find something just is not talking to something else. If the traffic doesn't flow from A to B, what's gone on? Is it perhaps a routing issue? It quite often is. That's one of the main reasons why network traffic doesn't flow from A to B, because the routing isn't correct. Maybe there's something blocking the traffic. So that might be a firewall, it might be an NSG, it might be a software based firewall, such as Windows Firewall or Defender. Or maybe it's a DNS issue. Well, we've all been there with DNS. That's quite often a problem as well. But there can be lots of different things that can go wrong. So, how can you see what's happening? How can you look under the covers and see what is going on in terms of the network traffic? Remember, it's software defined networking, and Microsoft manage a lot of this stuff for you. So, how can you really see to the level you could see what's happening on premises with Azure? Well, there are some useful tools there to help you. So let's have a quick look at some of the options that we've got. So first one I wanted to mention is Azure Monitor. So this now has a really useful network insight displayed, and that will allow you to look at things like the network health and the metrics behind that. You've got a connectivity section where you can look at your VPN connections and ExpressRoute, for example. You have a traffic section where you can look at the traffic flowing or not flowing between those networks. And you've got a diagnostics toolkit, which really is a link to the next slide, which is Network Watcher. So this would be something I would be quite familiar with. I've used it quite a lot over the years and found quite often it's really helped me out. So Network Watcher is really a set of tools that will really help you with your virtual network troubleshooting. Now, unfortunately, many of these tools will require a running virtual machine on the network in question. So if you've got traffic on a particular VNet that does not seem to be flowing, you may need to deploy a VM if you don't have one there already. The reason for that is Network Watcher will put an agent on that VM and use that host then to perform some network tests for you. So some of the tools here are network topology, which really just gives you a visualization of your virtual network, a nice network diagram. Just if for complex networks, this can be helpful just to see how things look from a visual point of view. You have IP flow verify, which will help you diagnose connectivity issues between different resources. You have next hop, that will show you the next hop of your traffic. So when you're using things like user defined routing, you're trying to perhaps send traffic from your machine into an Azure firewall, you can see, well, is the next hop the IP address of the Azure firewall? Maybe it's been misconfigured. Maybe it's sending straight out to the internet and never hits the firewall. So this will verify the next hop has been set up correctly. You have VPN diagnostics. So if you've got issues with your VPN, you can troubleshoot those gateways, those managed gateways I mentioned earlier, and see if there's any issues with those or with the actual connections themselves between the VPN gateway and your destination VPN connection. We have VNet flow logs, which is a relatively new service that helps map the traffic flow through your entire virtual network. And we have a connection troubleshooter, which will show the connectivity between a source VM. So I mentioned you might need to deploy a source VM for this purpose of the test, and a destination VM. So that VM might be on premises, for example. So you can see is there any connectivity between your VM in Azure and your destination VM on premises. So VNet Flow Logs is fairly recently gone to GA, and this, I suppose, will replace a service that's been there for a while called NSG Flow Logs, which needed to be enabled on the NSG level. So VNet Flow Logs do also need to be enabled. You do need to store this traffic. There will be some cost to that, but they go beyond the NSG level, and they will look at the flow over your entire virtual network. So we'll look at information on your ingress and egress IP traffic over the whole VNet. Those logs will be stored in a JSON format that you can later download, and it will show you the outbound and inbound flows per network rule. And that JSON obviously can be quite difficult to read, especially when there's a huge amount of it. So you can use some visual aids to help display that. So there's some tools for that. You can use Power BI or a third-party tool like Kibana to help you to manage that. So logs is a really great way. If nothing else is working, if you're finding some of those other tools just aren't helping you to get to the bottom of a problem, you may have to just revert to using logs, but at least the logs should give you enough information to help you to get to the bottom of any issues that you have. So that's it. That was my session. Thank you very much for watching. I hope it helped in some shape or form. So just to wrap up, please do feel free to reach out to me. You'll find me on LinkedIn and Twitter, and my blog site is azureallen.ie. And thanks again for watching, and enjoy the rest of Azure Back to School. Bye.